Okay, let's get started. So today we're going to finish off with conic sections. So we're going to go through sketching the parabola, the ellipse, and the hyperbola. We'll go through an example of each. Then in the tutorial, there are plenty of examples, so you can pick a few to try out. And then after that, we'll have a look at these conic sections in polar coordinates. So very similar to what we did before, converting graphs from Cartesian to polar, polar to Cartesian. We're going to do a similar thing here to see what is the polar coordinate version of these three. Okay, so last time we left off with the hyperbola, and then for homework, you had to get the shape from this equation. Did everyone do the homework? No? Okay. Please go over that. So you end up with this Cartesian form, and you should have gotten the shape over here. Yeah. And while doing the homework, you would have gotten this bit on the side. C squared, remember that's the focal points over here and over here, is equal to A squared plus B squared. And that was these bottom values here. Okay, so today we're going to find the vertices, the focal points, and the asymptotes of the hyperbola. Now, the vertices and the focal points depend on the orientation. The vertices and the focal points depend on the orientation. Okay, and we saw a bit of that when we looked at the parabola. So if the parabola was facing up, you had the focal points at the top. If the parabola was facing down, the focal point was at the bottom. And then if it was facing left or right, the focal points would change as well. So we have a very similar thing here for the hyperbola. Here there are two orientations. Right, the parabola had those four, and we wrote up that table for it. So we have the one orientation where it goes left and right. So that will look like this. Okay, so we got our asymptote lines, and then the hyperbola will go left and right in those asymptote lines. So you end up with something like that. So the focal points and the vertices will then be along the x-axis. So we can put that in blue here. So we got the vertex and the focal points, and we got the vertex and we got the focal points. Okay, so that will be along the x-axis. If we look at the other orientation, the vertical orientation, very similar, will be like this. So you have your asymptote lines again. Okay, but now it will be vertical, so it will be like this and like that. And again, we can fill in the vertices and the focal points. So you'll have the vertex there, focal point above, vertex there, and focal point below. So for this orientation, you see that the focal points and the vertices are vertical. Okay, so please keep that in mind for the two cases. And then just a reminder for the first one, that will be x squared over a squared minus y squared over b squared is 1. So the x part comes first, so it's going to be horizontal. And then in the second case, we have y squared over b squared minus x squared over a squared is 1. Now the y comes first, and so it's vertical. But you would have seen that in the homework. Okay. So how do we find these? Well, in the first case, for horizontal, we can write f1 is going to be minus c 0. Okay, so the x value is minus c for that left-hand side. And then for the right-hand side, f2 will then be plus c and 0. Okay, the left and the right one. Very similar thing for the vertices. So v1 for the left, that will be minus a0. Right, because a goes with the x, so minus a0. And then the one on the right, that will be plus a0. Okay, again, the y value is 0, because this is the horizontal hyperbola. And then for the vertical, so now we're looking at the y values, not the x values. This will be 0 c for the top one, 0 minus c for the bottom one, and then the same sort of thing for the vertices. So we have v1, that will be 0b, right? Because it goes with y, so we use b for the top one, and then v2 is 0 minus b for the bottom one. Okay, so depending on which orientation you have, you either use the horizontal one for the vertices and focal points on the left and the right, or if it's vertical, you use the vertices and the focal points for the top and the bottom. Okay, and in either case, we have the same asymptotes. Okay, so the asymptote lines, those are given by y equals plus or minus b over a x. Okay, that's the same in both cases. So b, that goes with the y, a goes with the x, and we have the plus and the minus for the two of them. So the plus one, obviously you're right, that's from the third quadrant to the first quadrant, and then the minus one, that's the other one. Okay, let's have a look at what happens if we shift the conic sections. So in the tutorials, you'll need to know if they are shifted or unshifted. Okay, so you should be familiar with that from before. You take a function, you move it left, you move it right, same idea. Okay, shifted conic sections. Okay, it's exactly the same as what you did before. So if we have an ellipse, we can move it left and right, we can move it up and down. So we can write it as x minus h squared over a squared plus y minus k squared over b squared is 1. So this is shifting to the right by h and up by k. So to the right by h and up by k. And if we shift the whole graph to the right and up, remember the vertices and the focal points will also be shifted. Okay, so just keep in mind, v and f will also be shifted. Right, because if you shift the whole graph, the vertices and the focal points go with it. Similar thing for the parabola, so we can have x minus h is equal to, for g equals y minus k squared, something like that. So we just took the formula from before, and then x gets shifted by h, y gets shifted by k. Same idea. Okay, and lastly, for the hyperbola, we can shift that as well. Right, same idea. You're shifting x, you're shifting y. Okay, and then just a final note here. Asymptotes will also be shifted. So the vertices, they get shifted, the focal points get shifted, and then for the hyperbola, that comes with asymptotes, those are also shifted. Yeah, so everything gets moved by h to the right and k up. All right. Any questions on shifting these? Okay. Let's have a look at sketching now. So number one, the parabola. Okay, so we'll do one of each just for time. Then the rest of them, you can have a look at the tutorial. So the solutions are already up, so you can have a look at those. Okay, so we've got y minus 2 squared equals 2x plus 1. Okay, so it's a parabola. What we want to do is find the points, so the vertex, focal point, and so on, and then sketch it. Okay, so firstly, note that this is not in standard form. Okay, we've got that 2x plus 1. That is not the standard 4 times p that we need. Okay, so big note here, not in standard form. Right, we want something more like from the last lecture. We want something like that, one of those two. Okay, that's standard form. That plus 1 on the end there, we want to get rid of that. Okay, so let's go back here. So how do we write it in standard form? So firstly, that x we want to be by itself. So let's factor out that 2. So we're going to have y minus 2 squared is equal to 2x plus a half. That's looking better. But we want the 4 in the front. Okay. Currently we have a 2, but that's fine. 2 is just half of 4. So this is going to be y minus 2 squared. And this will be 4 times a half, x plus a half. Okay, now it is in standard form, and we can identify what we need. Firstly, it's 4 times p, so p must be a half. And we see that it's shifted, so the y value is shifted by 2 up, so k is 2, so we shifted up by 2. And x is also shifted to the left by a half. Okay, so that is shifted to the left. All right, so we have everything we need to find the vertices and the focal points and so on. Okay, so the vertex, what's that going to be? So if we forget about the shifting, the vertex should have been at 0, 0, right? That was the standard vertex position. So it was at 0, 0, and now what did we do with it? We shifted it to the left by a half, and we shifted it up by 2. So we take 0, 0, left by a half, up by 2. So that's minus a half, 2. Okay. Or you can write it in terms of the h and the k. Okay, so there, the h, that's the x part of the vertex, and the k, that is the y part. Okay, or you can think of it as starting from 0, 0, shifting to the left, shifting up. Okay, what about the focus? Remember what that was? That was the p value. That tells you where the focus is. So here, it's going to be at minus a half. Okay, but then we're shifting to the left by a half, so that's going to be plus a half. And we're shifting up by 2, so 2. Okay, so again, we started at minus a half, 0. We shift to the left by a half because of the shifting in x, and we shift up by 2, so that gives you the 2. So this will be at 0, 2. Okay, and finally, the directrix. Okay, what's that going to be? That will be x equals, well, it was at minus a half, right? Because p is a half, so x will be minus a half. Then we shifted left by a half, so minus another half, so that'll be minus 1. Okay, so it's always whatever the p was, so x equals minus a half, or x equals minus p, but then we go left by a half, so we need to minus a half from it. Okay, so with this 3 stuff here, we can then sketch. So let's set up our axes. Okay, the directrix is at minus 1, so let's put that in. Okay, what about the vertex? That was minus a half, 2. So that's in between those 2 lines, up a bit. So that's the vertex V. And then the focus, that was at 0, 2, so that's going to be over here. Okay, and then we just draw in our parabola. So it's going to be horizontal, and it will look something like this. Okay, so you just fill in the parabola on that side there, right? Because the directrix is on the left there, so then your parabola is on the right. Okay, again, if you forget your orientations, go back to the lecture here. Where is it? Here. Right, the 4 the full orientations of the parabola. Okay, so we were looking at this case here, right? Because our p was greater than 0. So it's this one. Okay, so here p greater than 0. Right. Any questions on this first example? No questions. Okay. And you don't have to worry about filling in all the other points and stuff. As long as you got the vertex, the focus, the directrix, the rest you just freehand in place there. Okay, let's have a look at the ellipse. Okay, so we've got an example here, 9x squared minus 18x plus 4y squared is equal to 27. Okay, again, first thing, this is not in standard form. Okay, if you have a look at the tutorials, most of them are given in a non-standard form. So before you do anything, you have to write it in standard form, and then you can continue. So please just keep that in mind for the tutorials. So it's not in standard form. We want to write it in standard form. So the x terms over there, we need to group together. The y squared is already by itself, so we can leave that alone. So let's focus on the x first. So we want x by itself, so let's factor out that 9. So it will be 9, x squared minus 2x. Okay, we're going to group those together. Plus 4y squared equals 27. Okay, now what can we do with this x squared minus 2x? We just want x by itself, so what do we have to do? How do we combine it? Yeah. Okay. Yeah, what's the process called? Starts with the C. Completing the square, yeah. Okay, so we're going to have 9 x minus 1 squared minus 1. Okay, so we do the completing the square there. Plus 4y squared is 27. Right, so we just have a single x that we want there. Okay, so that's going to be 9 x minus 1 squared minus the 9 from distributing there. Plus 4y squared is 27. Okay, we can take the 9 over to the other side. So we get 9 x minus 1 squared plus 4y squared is, take the 9 over, it'll be 36. Okay, now still not in standard form because that right-hand side there is not 1. Okay, so that this side must be 1. Okay, well, that's easy. We just divide through by 36. So we're going to have 9 x minus 1 squared over the 36 plus 4y squared over the 36, and that's 1. Okay, so that's all done now. Okay, so 9 at the top, 36 at the bottom. We can simplify that to a 4 at the bottom there. So that will be x minus 1 squared over 4. And then we've got the 4 at the top, so they'll simplify to a 9 at the bottom. Okay, now this is in standard form. Okay, so once it's in standard form, we can then continue finding the vertices, focal points, and then we can sketch this. Okay, so the number underneath the x there, that will be our a squared. So a squared, that will be 4. So a will be 2. Okay, remember, whatever number there is squared. Okay, it's a squared at the bottom. And then for y, that's going to be b squared. So b squared is 9. So b is 3. Okay, again, those numbers are squared. All right, so we got a and b. We're missing c. Remember, those were the 3 things we needed. So how do we find c? Well, we know for the ellipse, b squared is a squared minus c squared. Okay, and we can use that to then find the missing value. So b squared, that was 9, a squared, that was 4, c squared, we don't know what that is. Okay, so c squared will be 5, so c is root 5. Okay, so that gives us our focal points, that c value. So c gives us our focal points, a and b, that gives us our vertices. All right, so we have everything we need. We've got a, we've got b, we've got c, so we can fill in the rest. So what are the vertices going to be? Okay. So here it's going to be, we go up here. So is this going to be stretched along x or y? Because we're looking for those endpoints. Y, yeah, it's going to be stretched along y. So it will be, x will be 0 and y will be something, because it's along the y-axis. So this will be 0, 3. So we're looking at these points over there and over there. Okay, so it'll be 0, 3. But, yes? Because this is bigger. I did mention it last time, but I'll say it again. So here, this a squared and this b squared, that tells you how this ellipse is stretched. So if this b squared is larger, it is stretched more along y. If the a squared is larger, then it's stretched along x. Okay, it's which way is it longer, basically? The major axis and the minor axis. Okay, so we've got that. But remember x being 0 here. But we need to remember that this is shifted. Yeah. So it's shifted to the right by 1. So here we have to put a +1. Okay, so our vertices will be 1, 3, and 1, -3. So that'll be for the top one and the bottom one. Okay. What about the focal points? That will be somewhere there, somewhere in between. So focal points. Okay, same as before. So it will be 0, root 5, but it's shifted to the right by 1, so we have to put a +1. So we end up with 1, root 5 for the top one, and 1 minus root 5 for the bottom one. Okay, so that'll give us our top and bottom focal points. Okay, now we need to sketch this, so let's put everything together. Okay, so we've got x and y. Let's fill in our top and bottom vertices. So it'll be 1 and 3, and then 1 and -3. So there and there. Okay, so the ellipse must be stretched between those 2 points. So it'll be something like this. Okay, and then the focal points, that will be somewhere there. So we've got V1 and F1, and then F2 and V2. Okay. And then these points over here, over there and over there, that will be these A values here. So A was 2, okay, but we shifted it across. So this point on the left here, that will be -2, and again +1 because we've shifted across. And this other point, that will be 2, and again +1 because we shifted across. All right. Okay, as long as you got those 4, then you can just connect the dots to make the ellipse. Any questions? No question. Okay, again, just keep in mind if you have some general ellipse, something like that. So this one is stretched along x, so that would be the major axis. Okay. And then the other one, that is the minor axis. Okay. So again, keep in mind, depending on which one's larger between A and B, you either have your major axis going along horizontally, so that's when A is larger, or you'll have the major axis going vertically, that's when B is larger. Okay, and then these points here, that will be 0 minus B, 0B, A0, and minus A0. Okay, that was from last time. So just keep that somewhere in your book so you can refer to it. Okay, any questions before we move on? Yep. This bit. You good? Yeah. Any other questions before we move on? Yep.
Question asked us. Sketch the following function.
Yeah. You'll get something like this, something like that, and the thing will say, sketch this. Okay. Okay, last thing, the hyperbola. Okay, so again, you're going to get some expression. It probably won't be in standard form. You write it in standard form, get your vertices, focal points, and in this case, asymptotes, and then you just fill in the details. Okay, so here we have x squared minus y squared plus 2y is 2. Okay, now the talking needs to stop. Okay, so x squared minus y squared plus 2y is 2. Again, not in standard form. We need to fix that. Okay, so firstly, we've got 2 of those y terms. We only want 1. So we need to put those together. So we're going to have x squared minus y squared minus 2y is equal to 2. So we put those together, and then we need to complete the square on that. So that's going to be x squared minus y minus 1 squared minus 1. Okay, so x squared minus y minus 1 squared is 1. Okay, so this is in standard form, so we can continue from here. Okay. And from the standard form, we see that x is not shifted, so that stays where it is, but y is shifted up by 1. So whatever points we get, vertices, focal points, asymptotes, all of those, once we found them, we need to shift them up by 1. So you find them in the normal way, and then shift up. Okay. Also, notice that these are just divided by 1. Okay. So a squared and b squared are both 1 in this case. Okay, so let's fill in what we know. So a squared is 1. So a must be 1. B squared is also 1. So b must be 1. So we've got a and b. C is missing, so we can find out what that is. So c squared is a squared plus b squared. So that will be 2. So c is root 2. So a and b, that gives us our vertices, depending on the orientation. And c, that gives us the focal points. Okay. So we'll find those, and then we'll find the asymptotes. Okay, so vertices, what are we going to have? Okay, there's going to be two of them, and it will depend on the orientation, if they are left and right or up and down. So looking at this, which type is it going to be? Is it going to be on the left and the right or up and down? What comes first? So which one is it going to be? Left and right. So the vertices, will it use A or B? A. Or use A. They're both the same in this case, so if this was in the test, you got the marks already. But it will be A. Okay, so what is it going to be? So it will be -1, 0, because it's along the x, but it shifted up. So we have to +1 on y. Okay, what about the other vertex? X will then be +a, so it will be +1. Y will be 0, because it's along the x-axis, but it shifted up, so +1. Okay. So again, if you ignore the +1s there, -1, 0, that is if it was on the x-axis, but it shifted up, so we have to add 1. Okay, what about the focal points? Okay, similar thing. It's going to be left and right. So it will be -√2 and 0. So that is if it's along the x-axis, but it shifted up, so +1. Okay, so that's for the left one, and then the one on the right, that will be √2 and 0, but it shifted up, so +1. Okay, so we end up with that. But now for hyperbola, we got one more thing to do. That's the asymptotes. Okay, so that's going to be y equals plus or minus b over ax standard. Okay, so y is equal to b and a, they're both 1, so it'll just be plus minus x. But again, it shifted, so it needs to go up by 1. So -1. Okay, so again, whatever shifted, you do everything exactly the same, and then at the end, you just shift everything up. So like we did here, the vertex was -1, 0, but then shifted up. Focal point was -√2, 0, but then shifted up. The asymptote was y equals plus or minus x, but shifted up. You always just add the but shifted up every time. Okay, so this will give us two asymptotes, one with the plus, one with the minus. So it will be y equals x plus 1 and y equals minus x plus 1. Okay, you got your plus asymptotes and your minus asymptotes. Okay, and finally, we can put everything together to sketch this. So x and y. So x plus 1 and minus x plus 1, they're going to intersect at 0, 1. So that's going to be somewhere over there. Let's put in the asymptote lines. So it will be, that's for our plus asymptote line, y equals x plus 1. And then the minus asymptote line, that will be there. Okay, and then they intersect at that middle point. Now we know it's a hyperbola going left and right because the x part came first. So we're going to have a hyperbola branch over there and over there. The vertex over here, that was at -1, 1. And the vertex on this side, that was 1, 1. Right, that was the V1 and the V2 that we got from here. Okay, and lastly, the focal points. Let's plot those. That's going to be, let's put that in blue. There's going to be one over there. And there's going to be one somewhere here. Okay. So we've got the hyperbola in pink. We've got the two vertices in white there. And then the two focal points in blue. All right. Any questions on this example? Okay, so again, everything's exactly the same as what we did last time, but now you just have to include that shifting. So the vertices, the focal points, the asymptotes, you calculate it exactly as we did last time, and then just the plus k and h, depending on how you're shifting. Yes. The b squared. Yeah, no, because the vertices will be left and right. There's no up or down vertices. No. So for the ellipse, you use both. So you get the 4 points. For the hyperbola, it will only be one of them. So here it was A. If it was a vertical one, then it would be the B that you use. Okay. That just goes back to what we did. Where's it? Over here. It depends on which one you use. There. So you would pick which one. Okay. Let's get back. Right. Any other questions? No questions. Okay. Last thing for today, converting this into polar coordinates, and then we're going to be done with conic sections. Okay, next week we're on to sequences and series. Yeah. It's a lot. Yeah. So we got sequences, series, Taylor series, complex numbers, and then we're done. Yeah. Yeah, that'll be it for the semester. So sequences, series, Taylor series, complex numbers. So four more chapters. Okay, conic sections in polar coordinates. Okay, so let's start off with a definition. Well, it's a theorem, but we're not going to prove it, so you just take it as a fact. Okay, so let's F be a fixed focus point. So exactly the same as what we did for the parabola. So you fix some focus point. And let L be a fixed directrix line. Okay, so we've got a focal point and we have a directrix line. Let E be a fixed positive number. Okay. Called the eccentricity. Okay, so new word for today. So focus and directrix, we know that from the last lecture. We've got this new word here. Okay, so that's E. Okay, then the set of all points P. Okay, such that PF over PL equals E. So we take the distance from point P to F, and then the distance from point P to the directrix line L. That's going to be equal to E. Okay, so the set of all these points is a conic section. Okay, so again, we won't prove this in general. We'll do one example just showing it. So it's a conic section. The conic section is okay, and then we got the three cases. So number one, an ellipse. If E is less than 1. Okay, so if E, this eccentricity is less than 1, then it's an ellipse. Number two, it's a parabola if E is equal to 1, and that's just straight from the definition. So if we go back to the previous lecture, right, the distance from F to P, that was the top part of our numerator, divided by the distance from P to the directrix line, that was E. But FP and P down to the directrix line, by definition, for a parabola, those are equal. So for a parabola, E is 1. Okay, so this is just from the definition. Okay, and if E is greater than 1, you could probably guess what that's going to be. That will be a hyperbola. Yeah. So if it's between 0 and 1, it's an ellipse. If it's exactly 1, it's a parabola. If it's greater than 1, then it's a hyperbola. Okay, so like I said, we're not going to prove this in general. We're going to have a look at a specific case for the parabola when E is 1. But you can do exactly the same thing for the other two. Okay, so the parabola case. Yeah, and we're going to do it in the polar form. Okay, so we're going to set up our axes. Okay, we've got our parabola. Okay, I'm going to shift it a little bit. So before we had the parabola at the vertex, at the origin. We're going to shift it down a little bit, such that the focus is at the origin. Okay, so in other words, we take our parabola and we shift it down by P. So here is our focal point at the origin. Okay, then we've got the vertex somewhere underneath that, and then the directrix line under that. Okay, so again, it's exactly what we did on Tuesday. We shift it down by P. Okay, so what we're going to do is introduce our polar coordinates to convert it from the Cartesian form that we did on Tuesday to now the polar form. So we're going to have our radius r, okay, and the angle theta. Okay, and then this over here, that will be our point P, going down to our directrix line at the bottom there. Okay. Okay, so that's the same setup that we had last time, but now in polar coordinates, but same idea. So what we want to do is start off with this equation here, and then end up with the polar form for this. So we need PF over PL is equal to E. Right, so for the parabola, this would be 1, but we're going to leave it like this for now, and then later we'll change it. Okay, so PF, what's that going to be? That's this hypotenuse line, so it'll just be the radius. Okay, what about PL? PL, that's going to be this y part, plus this bit underneath here. Let's just call that D. Okay. So this y part, that's going to be r sine theta, and then this distance here, I'm just going to call that D. Okay, so the total distance, that will be the y part, plus D. But the y part, that is going to be r sine theta. Okay, so we end up with that. So technically it's in polar form. We got the r and the theta, but what we want now is to make r the subject. Okay, so let's take that denominator over to the other side. So we're going to have r is equal to re sine theta plus de. Okay, so we just took that over there. Then the re sine theta, we're going to take over to the other side. And then we'll divide by that bracket part. Okay, and that's our polar form. So for a mixing them up, for a parabola like we have here, E would have been 1. You would have fixed that at 1. But this works for any E, right? We didn't fix it to anything. So for this example here, it was a parabola, so E would have been 1. But again, this works in general. It doesn't matter what you set it up as, you end up with the same thing. Okay, so you get the same thing. For an ellipse or hyperbola. Okay, so for homework, you're going to do it for an ellipse. So I'll show you the setup and then you can do the rest. So we're going to have one of the focal points at the origin. So say F1, and then the other one we'll have somewhere else. Okay, so we've got our ellipse shifted over to the left so that the focal point is at the origin. So what you're going to do is exactly the same thing as we did for the parabola case. Okay, here we've got R and theta, and that's point P. Okay, so exactly the same. Do this for the ellipse, and you should end up with the same formula like this. Okay, now just a little note with the sign here. So you might have noticed from the polar curves sketch, if you did a few of those tutorial problems, if you had something with sine, so like r equals 2 sine theta, that was a circle at the top. If it was r equal 2 cos theta, it was a circle on the right. This sine and cos tells you whether it's vertical or horizontal. So here we could write this as r equals ed over 1 plus or minus e cos theta. So if you use cos instead of sine, then the parabola will be facing left or right. And if you use sine, it will be facing up or down. And that's where this plus or minus comes in. So here, if you do the plus or the minus, and you got cos, it will be left or right. And if you have r equals ed over 1 plus or minus e sine theta, that will be up or down. Okay, so it's the two cases. Okay, so again, the cos, that means it's horizontal. And if it's a plus, then it's going to be facing left. If it's a minus, it's facing right. Yep, and then similar on the other side, the fact that there's a sign here, that means it's vertical. And if it's a plus, it will be facing down. And if it's a minus, it's facing up. Okay, so you can go back to what we did for the parabola. So facing up and down, facing left or right. You got the same 4 cases. All right. Any questions? No questions. Okay, let's just have a look at a quick example with this. Okay, so again, you're all familiar with the Desmos. So we have R is equal to E times D. So do you want ellipse, parabola, or hyperbola? Ellipse. Okay, so what does E have to be for it to be an ellipse? Something between less than 1. So let's take a half. Okay, so that will be our E value. Then we need D, that will be the directrix. Let's say 3, something like that. Then we have 1. Okay, don't worry about that yet. Now we need plus or minus, or plus or minus E sine theta or cos theta. let's do sine theta with the plus. So we have our eccentricity, sine theta. There we go. We have an ellipse. And notice it's facing down. Okay. So we end up with that. We can change this eccentricity value. Let's make it 1. And we have a parabola. And if it's more than 1, we get our hyperbola. Okay. So you can play around with this, choose different values. Then in the tutorial, the last bit of the tutorial, we'll cover this. Okay, so there's different values of E and D you can choose, and then you need to figure out what shape it will be. Okay, and again, if we change this to cos, right, it goes left and right now. All right. Okay, so again, do that last bit of the tutorial. That will help you identify, what shape it will be. Okay. Any questions? No. Okay, last bit of homework for today, then we'll leave. Okay, determine the eccentricity of the ellipse. Okay, so we got x squared over a squared plus y squared over b squared equals 1 in terms of a and b. Okay, so I'll give you a little hint on what to do. So here we've got this in Cartesian form, okay, x and y. But to find the eccentricity, we need the polar form. So we take this Cartesian form, convert it to polar, and then we can identify what E is. Okay. So convert the Cartesian form to polar form. Right, you'll get something like this. And whatever's in front of the cos or the sine, you're going to have some number there. That's your eccentricity. So that will be ED over 1 plus or minus E sine theta, or R equals ED over 1 plus or minus E cos theta, one of the two, depending on how you do it. And then whatever's in front of that, that's what we want. Okay, so you can try that out. Okay. Any questions on this? No questions. Okay, so please expect something like this for the class test 3. Okay, so for that polar coordinate section, polar coordinates, conic sections, you might get something like this. You have to use your polar coordinate knowledge to convert it to polar and identify maybe the directrix, maybe the eccentricity. You need to be able to identify that. Okay. Or, other way, if I give you the polar form, then you need to identify which one it is. So it will be, right, one of these three. So I'll give you the polar form, and you need to say, is it an ellipse, parabola, hyperbola? Right. Anything? Yep. Yep. Yeah, so you're going to write x is r cos theta, y is r sine theta. Okay, we know what r is. I gave it to you there. So you're going to take x and y, you're going to substitute it into here, and you're going to see what the r is. Okay, so put x in, put y in, solve for r. It will be one of those two. Okay, I'm not telling you which one, it will be one of them. And then you see what your E is. Okay. Anything else? Anything about the project for next Tuesday? Okay. Please do not show up on Tuesday not having done the practice thing. Okay, you're wasting your time. You're going to have an hour and a half. You're going to just be looking at it. Okay, please make sure that you do the stuff this weekend. If you can get into your groups, even better. If you're by yourself, just try it out. But please, if you get there on Tuesday and you haven't done it before, just don't come. Okay, you won't finish it. Okay, and it's closed book. Okay, so please practice. You've got that, the whole guidelines on how to do it. Do it at home. Come on Tuesday, do it again. Everything's easy. Yeah. No, I don't have any string for you. You must bring your own string. Good question, though. Before you show up with you're going to be using your shoelaces. No, you have to bring your own string. University doesn't give me any budget for you guys. Okay. Any string will be fine. If you get like a meter length, that's plenty in case you make a mistake cutting it. But yeah, string, ruler, pens, pencils, erasers, you need to bring all of that. And paper. Bring enough paper for your rough work. All right. Any other questions for the projects? Okay. See you Tuesday.